Tesla's humanoid robot Optimus is no longer just a futuristic concept. It is rapidly becoming a reality. Designed to handle repetitive or dangerous tasks in manufacturing and eventually assist in households, Optimus has progressed quickly, with the latest prototypes demonstrating smoother, more dexterous movements, and even the ability to handle delicate objects. Elon Musk has announced plans to significantly scale up production in the second half of 2025, with a vision to manufacture millions of these robots annually in the coming years, despite challenges related to the supply of rare earth magnets. So, how is the plan to produce thousands of Tesla Optimus units unfolding? Before we begin, please help us reach 6,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus and the latest news. At the core of Tesla's Optimus robot lies a series of high-torque electric motors that rely on powerful compact magnets, many of which are made using rare earth elements such as neodymium and dysprosium. These elements provide the magnets with the necessary strength to enable the humanoid robot to walk, grip, and interact with the world in a natural manner. However, an unexpected challenge has emerged. Around 90% of the world's rare earth magnet production is controlled by China. In recent months, China has tightened export restrictions on critical rare earth processing technologies and now requires companies like Tesla to obtain special licenses to import these materials. These moves are seen as part of a broader geopolitical strategy to maintain control over key technology supply chains and could potentially delay Tesla's ability to scale up production. As the world undergoes a dramatic transformation driven by automation and artificial intelligence, Tesla continues to assert its ambition to lead the way with its humanoid robot project, Optimus. Despite facing numerous challenges, particularly the risks associated with global supply chains, Elon Musk and his team remain optimistic about Optimus's future and have outlined a series of long-term strategies to realize the goal of mass-producing the robot. One of Tesla's top priorities is to reduce its dependence on material supplies from a single market. As a result, the company is actively diversifying its supply chain by seeking and establishing partnerships with rare earth mining operations in more stable regions such as Australia and Canada. This opens up the possibility of shifting the import of magnets and other critical components away from China, a country that currently controls the majority of the global rare earth market. Alongside efforts to expand its supply sources, Tesla is also investing heavily in research and development to create alternative technologies. Specifically, the company is focusing on developing motors that can operate efficiently without, or with only minimal use of, rare earth elements. A strategy Tesla has already successfully applied in the drivetrain systems of its electric vehicles. This approach is now expected to deliver similar breakthroughs for the Optimus robot. In addition, recycling initiatives are also a key component of Tesla's overall strategy. The company is ramping up efforts to recover valuable materials from used electronic devices, particularly rare earth elements found in batteries and old electronic components. This not only helps Tesla reduce production costs, but also contributes to addressing resource scarcity in a sustainable and environmentally friendly manner. Notably, Tesla is also considering the option of building strategic stockpiles of critical components, such as rare earth magnets. Although this approach requires significant financial investment, it is seen as a necessary measure to safeguard the company's production lines against potential disruptions caused by export restrictions or short-term fluctuations in global trade. With a forward-looking vision and a comprehensive strategy, Tesla is demonstrating serious preparation for a major technological milestone, the mass production of humanoid robots. The Optimus project is not only a symbolically significant technological product, but also a testament to Tesla's adaptability and unwavering determination in shaping the future. What did Tesla plan before starting production thousands Optimus units? The race to develop multifunctional robots is not just about hardware or AI, but also about securing the raw materials needed to create these machines. Rare earth elements are currently at the center of this global competition, As Tesla moves towards mass production of Optimus, the company's success will depend largely on navigating geopolitical challenges, as well as technical breakthroughs. In many ways, Optimus is a symbol of the future we're heading toward, a blend of advanced AI, advanced manufacturing, and strategic resource management. If Tesla succeeds, the next few years could mark the beginning of the age of robots, not just on Earth but potentially beyond. Optimus is not only advancing on the supply side but is also rapidly evolving in form and function. Tesla recently released videos showing the robot walking with a more natural gait mechanism, thanks to reinforcement learning in a simulated environment. The new model moves from heel to toe with swinging arms, mimicking human movement more convincingly than ever before. Another major breakthrough is Optimus's new hand. With 22 degrees of freedom, twice the flexibility of previous models, the robot can now grasp and manipulate fragile objects with high precision. This level of control is crucial for both manufacturing and potential household applications, where it could eventually assist with everything from sorting packages to preparing simple meals. Compared to the human hand, which has 27 degrees of freedom, Tesla's Optimus is considered to match the extraordinary flexibility of the human hand. Perhaps Tesla's next plan is to upgrade the hand's degrees of freedom to 24 or 25, something no humanoid robot manufacturer has achieved yet. Tesla's current plan is to deploy Optimus first in its own massive factories, where the robots will take on repetitive or ergonomically harmful tasks. But the long-term roadmap is much more ambitious. Musk has proposed sending an Optimus unit on a SpaceX Starship mission to Mars in 2026, aligning with his vision of using robots to support space exploration and off-world colonization. That would mark a historic moment, sending the first versatile humanoid robot to another planet. What makes the Tesla Optimus more affordable? Amid the rapidly growing humanoid robot market, Tesla has set a target price of just $20,000 for its Optimus robot. This price is considered highly competitive for a robot with such high potential for applications in manufacturing and service industries. However, analysts warn that to achieve this target price, Tesla will need to fully leverage cost-efficient supply chains in China, a strategy currently challenged by ongoing trade restrictions. Meanwhile, competitors from China are putting significant pressure on pricing. For example, Unitree, a prominent Chinese robotics company, is currently offering its humanoid robot G1 at a price of just around $16,000, substantially lower than Tesla's projected price. In addition, another Chinese company, Agabot, has announced plans to produce 5,000 robot units in 2025, matching Tesla's production target for Optimus during the same time frame. Although in terms of features and technology, Chinese humanoid robot models have yet to achieve the same level of sophisticated autonomy as Tesla, bolstered by its superior AI and proprietary advantages. Competition from Chinese companies is not limited to lower costs. Their strength also lies in rapid production capabilities and large-scale output, enabled by domestic supply chains and a vast pool of engineers. This presents a significant challenge for Tesla as it strives to maintain both quality and its competitive edge in price and production volume in the global market. Tesla Optimus carries high expectations both technologically and commercially in the humanoid robotics space. But the ability to compete on price with Chinese rivals will be a key factor in determining the project's success during its initial launch phase. This has prompted Tesla to explore long-term solutions and consider leasing or trial programs for the Optimus robot before the company reaches full-scale production capacity. Initial estimates suggest that the robot could eventually be sold for around $10,000, though this remains speculative. This pricing strategy is aimed at making the technology accessible to both businesses and potential consumers. Consumer expectations are centered on practical applications in both households and businesses. Market research indicates strong interest in robots capable of performing household chores, assisting with elderly care, and handling hazardous industrial tasks. The launch will likely follow Tesla's typical rollout model, delivering first to commercial clients before expanding into the consumer market. This approach allows the company to refine the product while generating revenue from business applications. Why Tesla Bot could completely change how Tesla factories operate. Before delving into the deployment mechanism of Optimus on the Cybercab production line at Giga, Texas, it's important to view the broader picture. The world is entering a phase of large-scale industrial transformation, in which artificial intelligence plays the role of an accelerating catalyst more powerful than any previous prediction. Even Tesla, long known as a leading electric vehicle manufacturer, is restructuring the very nature of its operations. Gradually, Tesla is no longer merely an automaker, but is repositioning itself as a technology conglomerate with deeply integrated AI at the core of its development strategy and product ecosystem. From the full self-driving FSD system implemented in Tesla vehicles, to the humanoid Tesla Bot Optimus, and even the Dojo supercomputer, a specialized hardware infrastructure developed in-house by Tesla to train large-scale AI models, all reflect Elon Musk's clear direction to integrate AI into every layer of technology that Tesla builds. One standout feature is post-assembly autonomy, where robots, immediately after being completed on the production line, can autonomously move to designated areas without manual intervention, much like how FSD-equipped vehicles can drive themselves out of the factory. In reality, for artificial intelligence to truly become powerful and groundbreaking, that is, to go beyond the digital realm and enter the physical world, Tesla has developed Optimus, a highly advanced humanoid robot. Think of it from a technical perspective. While pure AI can guide you through fixing a leaking pipe, an AI system integrated into an electromechanical robotic platform like Optimus can physically perform the task itself, from identifying the problem and analyzing potential solutions to executing precise physical movements using actuators that mimic human gestures. This marks the boundary between a passive AI and an active humanoid robot with the ability to perceive and act within the real-world environment. Currently, the race to develop humanoid robots is heating up globally, stretching from research hubs in China to North America. However, in terms of public and market attention, Tesla's Optimus still holds a prominent position. This is not only due to its technical capabilities, but also the brand value and curiosity that Tesla generates. Optimus is one of the few robots that has garnered both strong support and close scrutiny from the public, partly due to high expectations for the technology and partly due to skepticism surrounding Elon Musk's bold claims. Many are waiting to see just how far a company best known for electric vehicles can truly extend its technical capabilities into the highly complex field of humanoid robotics. According to Elon Musk, the development path of Optimus does not follow the conventional roadmap that most humanoid robots are currently pursuing. The entire system, from mechanical architecture to microcontroller structures and software, is fully designed and manufactured in-house by Tesla. The core objective is to optimize costs in order to make Optimus a commercially viable robotic platform at scale. A major strategic advantage for Tesla lies in its ability to repurpose components already optimized in its electric vehicle industry, including drivetrain systems, electric motors, battery modules, and high-power electronics. This not only significantly shortens development time, but also reduces production costs and enhances technical consistency. While competitors must start from scratch, developing each system separately, Tesla is leveraging its proven manufacturing capabilities, allowing it to shorten deployment cycles and gain an edge in the humanoid robotics race. Elon Musk has expressed strong confidence in claiming that the Tesla bot, Optimus, will be the most intelligent humanoid robot in the world, thanks to a design philosophy aimed at replicating human capabilities as comprehensively as possible. By integrating an AI brain developed entirely in-house by Tesla, along with sophisticated perception and behavioral algorithms, Optimus is configured to perform repetitive and monotonous tasks, the kinds of jobs people often avoid in real-world work environments. The second-generation Optimus has already achieved the ability to handle approximately 1,000 different tasks in operational settings. However, the real breakthrough is expected with Generation 3, the upcoming version, where the number of possible tasks seems virtually limitless. Just as humans have infinite cognitive potential limited by physical constraints, Optimus, equipped with actuators far more powerful than human muscles, can overcome those limitations, dramatically expanding its range of applications across manufacturing, services, and daily life. Although Tesla is globally recognized as a pioneer in electric vehicles, Elon Musk believes that Optimus could become the most strategically important product in the company's history. He has even predicted that, if successfully deployed at a global scale, Optimus could drive Tesla's market valuation to $25 trillion. A bold claim that reflects Tesla's long-term vision in the autonomous robotics sector. According to recent announcements, Tesla plans to produce at least 5,000 units of Optimus this year at its Fremont factory, with production expected to ramp up rapidly afterward. By 2026, the company forecasts an annual output of 50,000 robots. Looking ahead, Optimus is no longer just a standalone robot. It is steadily evolving into a robotic legion, representing the vision of a next-generation automated workforce in the post-industrial era.